All right, chapter 9.9 is very, very similar to 9.8. Okay, and the reason it's similar is because we're going to have an equation. We're going to pick x's. We're going to put them in a table. We're going to run it through the function, get a bunch of points, and we're going to graph the points. The difference between 9.8 and 9.9 is that 9.8 was all quadratic, and so you had x squared. And on your notes, I used the same table I created for 9.8 for your 9.9 notes. So if you'll notice on your table, the example equation, scratch that out on both of your, see how I've already whited mine out. You guys have an equation written in that box, right? Scratch that equation out. Those equations are from 9.8. I just forgot to take them out when I made it for 9.9. So if you notice the example number 2, what is the exponent? How is it different from yesterday's? How is number 2? Inlo? Exactly. Perfect. It's cubed instead of squared. So the squared gave us the U-shaped quadratic. The cubed is going to give us this little weird bent S looking, almost not S, but kind of, you'll see what I mean. It's going to give us a different looking graph. And then what's different on our second example? What's the exponent there? Yeah. For these, your exponent is the x. Your base isn't the x, or your base isn't the x this time. Your exponent is the x. And when your exponent is an x, it's called an exponential function. So a lot of x's there to remember that. But when your exponent is an x, it's called an exponential function. Okay. So we have quadratic functions that have a 2 in the exponent spot. We have cubic functions that have a 3 in the exponent. And then we have exponential functions that have an x in the exponent. Okay, those are the 3 we're going to deal with this week. So let's look at our example for the cubic one. Okay, and for the cubic one, we're still going to use the same x's as yesterday. So -2, -1, 0, 1, and 2. Okay. And you'll have to write it above because I forgot to erase this, but go ahead and put the equation that we're using here. So it's y equals, it's found right here on your notes, guys. That's the one we're using this time. So it's y equals -2x cubed minus 1. And again, we're going to plug in our x where it is, which is right here. We're going to plug in all of our x's. We're going to run it through. We're going to get y's. We're going to write them as ordered pairs. Now, with cubic, and this, it says on your homework or on your notes, cubic and exponential, this top one is the example of the cubic one. We're going to do exponential next. This does not have the same mirror properties as the quadratics. So you'll see here that you cannot use that nice kind of easy way to figure your +1 and your +2. You actually have to run all of these through. All right, so for the first one, we have y equals -2 times, and we're going to plug our x here, -2 cubed minus 1. Now, it's really important to remember the rules about when your base is negative and your exponent is odd. What kind of, just in the cubing part, not the rest of it. I'm going to write it down here because these are a lot of steps here. -2 cubed minus 1. So we are going to deal with the exponent first because PEMDAS says to, right? If you just as a reminder, we're doing PEMDAS here. We're going to do exponents before we do multiplication. And then last, we're going to do this subtraction and addition. Okay. So we have -2 times. I'm going to ignore that for right now. And I'm just going to cube -2. And cubing -2, be very careful here. It is such a common mistake to do -2 times 3. Okay. It's not. It's -2 times -2 times -2. -8. Good. Because it's a negative base and my exponent is odd, I know I'm going to have that odd man out. I've got 2 negatives that make a positive, and then that third negative makes me go back positive. And then -1. Next, PEMDAS says I do multiplication. So I have -2 times -8. -2 times -8 is +16 minus 1, which equals 15. So my y that I'm going to plug in is a 15, and I'm going to write my ordered pair -2, 15. Now I'm going to do the same thing here. Y equals -2. I'm going to plug a -1 in here, and I'm going to cube that. Yes, sir.
So you know how for our homework yesterday, how it's like it's -2 and 2 are the same thing, like this 2.
No, you don't get that mirror property with cubics. Yeah, unfortunately. All right, so we've got y equals -2, -1 cubed. All right, so we've got the -2. I'm going to ignore for right now because it's a multiplication, and I'm going to cube -1, which is -1 times -1 times -1, -1. Now I'm going to do multiplication. -2 times -1 is +2 minus 1. Now I'm going to do subtraction, and I get a 1. Now I'm going to do that again with a 0. I think I can probably do that up in the table, though. It's pretty easy. 2 times 0 cubed is 0, which is 0 minus 1, which is -1. Oops, I forgot to write my other one. -1, 1 was my point above that, and this point is 0, -1. And then I'm going to move on to +1. So y equals -2 times +1 cubed minus 1. And here's why the mirror effect doesn't work on cubes, is because when I cubed -1, I got a -1. When I cube a +1, I'm going to get a +1. So that's why cubes don't work like squares. So we have y equals -2 +1 cubed minus 1. I'm going to do the cube first, which stays a 1. -2 times 1 is -2 minus 1. -2 minus 1 is -3. Again, it's going through PEMDAS, making sure you're doing exponents first, then multiplying, then adding and subtracting. Yes, sir. Got it? 1 -3. And then last, I'm going to plug in a +2. So I've got y equals -2, 2 cubed minus 1. And remember, I'm going to cube my 2 first. So -2, 2 times 2 times 2 is 8. Okay. Remember that when you're cubing something, it's not taking it times 3. It's taking it times itself 3 times. -2 times 8 is -16 minus 1, and I get -17. So my point here is 2 minus 17. All right, so let's graph this. So I see that I'm going to have to go as high as 15 and 17, and my graph doesn't really go up that high. So I'll just make each spot worth 5. So I'll go 5, 10, 15, 20, and I'll go -5, -10, -15, and -20. All right, so let's graph these points. -2, 5. I'm going to go backwards 2, or -2, 15. I'm going to go backwards 2 and up 15. I'm going to put a point there. I'm going to go backwards 1 and up 1, which is just barely above the 0 since my first big block is worth 5. 0, -1 is right here. Notice that's your middle point, and I'll show you what happens at that middle point. And then 1, -3. And then 2, -17, which is down here between 15 and 20. I'm going to make my line a little bit thicker so that it shows here. So when I draw my graph or connect my points, I get this kind of bent graph. And notice where it makes the bend is this point right here, kind of that middle point, that 0 point. That's where it makes the bend. The only thing I will say about this is that notice my A here is negative, okay? If my A was positive, it would bend like this. So if your A is negative, or this front term right here is negative, it's going to bend one way. If their front term is positive, it's going to bend the other way. All right. All right. Now let's look at exponential graphs. Exponential graphs, 1, I think are a little bit easier, and 2, we use different X's. Okay, so we use different x's here. We're going to use 0, 1, 2, and 3. And I'm going to tell you right now, you can put a wiggly line on this bottom one. You only need to do 4 points here. For 8th grade, we're going to start at 0. When you get into algebra, you're going to actually use -2, -1, 0, 1, and 2. All right. But for 8th grade, we're just going to kind of stick to the positive side of it. So let's write our equation here that we're using, which is 3x is up in the exponent. So that means every time we plug an x in, it's going to be what goes up in the exponent. So we have y equals 3 raised to the 0 power, because I'm going to put a 0 in for the x, minus 4. What is anything raised to the 0 power? 1. Anything. 3 to the 0 equals 1. 100 to the 0 equals 1. Anything raised to the 0 power. So that's 1 minus 4. 1 minus 4 is -3. So it's the point 0, -3. Then we're going to plug a 1 in. So 3 raised to the first power minus 4. Well, 3 to the first power is simply 3. And 3 minus 4 is -1. So the point 1, -1 is here. Now you're going to notice what happens to our answers. Something happens very quickly here. Y equals 3 raised to the second power minus 4 equals 9 minus 4, which is 5. So the point 25. And then y equals 3 to the third power minus 4. Well, 3 to the third power, and be careful here, it's not 9, right? It's 9, or it's 3 times 3 times 3, which is 27. So 27 minus 4 equals 23. What happened to our y's very quickly? Yes, they got big really quickly. And the memory trick I always say, and it's a lot of X sounds, but it's X in the exponent is exponential and it explodes, meaning that Y gets big really fast, which is why we're not even going to do a 5th one, because that would be like 81, it'd be like 70 something. It's not even in the realm of our graph. So that's why we're not going to mess with it. So let's graph these points. And you'll notice our graph goes by 2's here, and we're still not even going to be able to graph one of our points, but that's okay. We're going to graph what we have. So we have 0, -3. I'm going to blow this up here. We have 0, -3. We have 1, -1. Notice everything goes by 2, so we got to be careful with 1, -1. Then we have 2, 5, which is here. And then we have 3, 23. So we're going to go over to 3, and obviously we are way, way, way up off of our graph. Now, I skipped doing a negative, but I want to show you just what would happen if we did a negative in the exponent. All right, so I'm going to do a -2 in the exponent spot just to show you. So my x here is going to be a -2. So if I do 3 to the -2 minus 4, what do we have to do to get rid of that negative exponent? We got to flip it and it becomes 1/9 minus 4. I know. And 1/9 minus 4 is 1/9. Where's it at? There it is. 1/9 minus 4 is -3.88888888. Okay. So if I graph that point, -2, -3.888, it's going to be right here. The reason I don't worry about that is because you'll mess with that next year. But the reason I wanted to show you where it goes is because if I'm going to erase that point and I'm going to put it back. Okay. That's that extra point I just did with a negative. A lot of people just want to graph it this way. And that's only half of an exponential graph. What the negative exponents do is they cause it to make a turn and run right along -4 forever. And we can't with a human eye do it, but getting closer and closer and closer and closer to -4 with never touching -4. All right. So this is called the tail. Okay. And this is called the head. So the notes I want you to write for yourself is that the tail is flat, at least as far as the human eye can see. It's actually not flat. It actually runs down just tiny, tiny, tiny bit forever. But as far as we're concerned with what our human eye can detect, we're just going to say it runs flat. And the head explodes or shoots like a rocket up high. And also, if you just make a note for yourself, if you have y equals -3 raised to the x minus 4, the graph would just flip-flop and do the other way. Your tail would run this way and your head would be exploding this way. So if it's a positive leading term, your tail's going to run to the left and your head's going to shoot up to the right. If it's a negative A, your tail should run to the right and your head should shoot up to the left. All right. Now, you do not need to worry about putting negatives in your table. You can worry about that in Algebra 1. Okay. It does need to be done, but we're going to deal with just the basics here. Just so you know, if I were to put negative exponents, these points would keep running this way closer and closer and closer to -4, but never touching it. And if I were to put in higher numbers, my head would just keep shooting up as high as possible. All right, so again, just I didn't label this, I did the other one. This is an example of exponential. And what makes it exponential is that the exponent is in the, or the x is in the exponent spot. So we have one example of a cubic, meaning the exponent is a 3. We had one example of an exponential, where your exponent is what you plug in with an x value, and those get really big really fast. So you can see here the difference of what your graphs look like between a cubic one at the top where you get the little S curve and the exponential where you shoot up really high with the head. And then yesterday's quadratics always give you the U shape. Sound good? All right. On the homework, you're going to do all of them because I've already blacked out the ones I don't want you to do to give you room to work. So I just kind of made you some workspace on your paper by covering up the ones I didn't want you to do. So do all of the ones that are left, which is still just 4 of them, and show all of your work. And if you're at home, email me if you have any questions.